Welcome to 11.4, our final section of the course, Matrix Algebra. This one, I might say, is my favorite section of the whole course. So, what we're going to do in this section is find the sum and difference of two matrices, find scalar multiples of a matrix, find the product of two matrices, find the inverse of a matrix, and solve a system of linear equations using the inverse matrix. So we're doing all of our matrix algebra operations. Here we go. Let's start with finding the sum and difference of matrix A and B. First, we're going to find A minus B, given our A and B here. So, A, 0, 1, negative 6, 1, 5, 4, minus B, 4, 1, 0, negative 4, 4, negative 4. Well, we have 0 minus 4, 1 minus 1, negative 6 minus 0, 1 plus 4, 5 minus 4, 4 plus 4. We just subtract each term with the corresponding term. So we have negative 4, 0, negative 6, 5, 1, 8. That's our difference, A minus B. And then for B, we're going to do A plus B. So we have 0, 1, negative 6, 1, 5, 4, plus 4, 1, 0, negative 4, 4, negative 4. This will give us 0 plus 4, 1 plus 1, negative 6 plus 0, 1 minus 4, 5 plus 4, 4 minus 4. So we have 4, 2, negative 6, negative 3, 9, 0. All right, now we're going to add scalars. So we have 2a minus 3b. 2a, so we have 0, 4, negative 2, 1, 1, 3, minus 3b, 4, 1, 0, negative 5, 2, negative 3. This gives us 0, 8, negative 4, 2, 2, 6. Minus 12, 3, 0, negative 15, 6, negative 9. This will give us 0 minus 12, 8 minus 3, negative 4 minus 0, 2 plus 15, 2 minus 6, 6 plus 9. Now we have negative 12, 5, negative 4, 17, negative 4, 15. Okay, matrix multiplication. For this, I always recommend thinking row, column, rule. So we take a row and we multiply it by a column. And then we take that row and we multiply it by the next column. And then we take the next row and multiply it by the column. And then we take that same row and multiply it by the next column. So we're doing the row, column, rule. So for AC, we're going to have A, 0, 5, -4, 1, 1, 3, times C, 3, 1, 2, 1, -2, 6. So we're going to take the row times the column. That's going to give us 0 times 3 plus 5 times 2 minus 4 times -2 for our first term. Next, we're going to take row times column. 0 times 1 plus 5 times 1 minus 4 times 6. Next, row times first column. 1 times 3 plus 1 times 2 plus 3 times -2. And then row times second column. 1 times 1 plus 1 times 1 plus 3 times 6. Okay, so now zero, 0. So we have 10 plus 8, 5 minus 24, 3 plus 2 minus 6, 1 plus 1 plus 18. This gives us 18, -19, -1, and 20. So this is A times C. And remember, in matrix multiplication, A times C does not equal C times A, unfortunately. Okay, C times A plus C times B. So C, 4, 1, 2, 6, -1, 1, times A, 0, 1, -1, 1, 2, 4, plus C is 4, 1, 2, 6, -1, 1, times B, 3, 1, 0, -4, 3, -4. So let's multiply the first C times A. We're going to get 4 times 0 plus 1 times 1. 4 times 1 plus 1 times 2. 4 times -1 plus 1 times 4. Then we have 2 times 0 plus 6 times 1. 2 times 1 plus 6 times 2, 2 times negative 1 plus 6 times 4. And lastly, negative 1 times 0 plus 1 times 1, negative 1 times 1 plus 1 times 2, negative 1 times negative 1 plus 1 times 4. And we're adding that to the multiplication of the C times B, which is 4 times 3 plus 1 times negative 4, 4 times 1 plus 1 times 3, 4 times 0 plus 1 times negative 4, 2 times 3 plus 6 times negative 4, 2 times 1 plus 6 times 3, 2 times 0 plus 6 times negative 4, and negative 1 times 3 plus 1 times negative 4, negative 1 times 1 plus 1 times 3, negative 1 times 0 plus 1 times negative 4. And now we get 1, 6, 0, 6, 14, 22, 1, 1, 5, plus 8, 7, negative 4, negative 18, 20, negative 24, negative 7, 2, negative 4. Adding these together, we end with 9, 13, negative 4, negative 12, 34, negative 2, negative 6, 3, 1. And that is our final. All right, let's find some inverses for each matrix. So to set this up, I'm going to make an augmented matrix with the identity, and then solve to make the identity on the other side. So what I'm going to do is multiply the row 2 by negative 4 and add it to row 1. So I guess I'll write that out. It might go a little quick. Negative 4 row 2 plus row 1. So we have 0, negative 1, 1, negative 4, 2, 2, 0, 1. Next, we will and switch it with row 1. So we will have 1, 1, 0, 1 half, 0, negative 1, 1, negative 4. Next, I'm going to add row 2 plus row 1. So I have 1, 0, 1, negative 7 over 2, 0, negative 1, 1, negative 4, negative 1 times row 2, 1, 0, 1, negative 7 over 2, 0, 1, negative 1, 4. So the inverse matrix is 1, negative 7 over 2, negative 1, and 4. Okay, let's find the inverse of this 3 by 3. Same setup. I'm gonna set it equal to the identity, and then reduce row echelon form until we get the inverse. All right, so first, let's do 3 times row 1 added to row 3. 1, negative 1, negative 1, 1, 0, 0, 0, 2, 1, 0, 1, 0. And then we have 0, negative 7, negative 3, 3, 0, 1. Okay, next, let's divide row 2 in half. 1, negative 1, negative 1, 1, 0, 0, 0, 1, 1 half, 0, 1 half, 0, 0, negative 7, negative 3, 3, 0, 1. Okay, let's do 7 row 2 plus row 3. 1, negative 1, negative 1. 1, 0, 0. 0, 1, 1 half. 0, 1 half, 0. 0, 0. 7 halves. 7 minus 6, 1 half. And then we've got 3, 7 half, 1. Okay. And now I'm going to add row 2 to row 1. 1, 0, negative 1 half, 1, 1 half, 0, 0, 1, 1 half, 0, 1 half, 0, 0, 0, 1 half, 3, 7 half, 1. And then multiply row 3 by 2. 1, 0, negative 1 half, 1, 1 half, 0, 0, 1, 1 half, 0, 1 half, 0, 0, 0, 1, 6, 7, 2. And then if we, you know what? I'm actually going to save this for a minute. And instead, I'm going to do row 3 plus added to row 1 and negative row 3 added to row 2. Let's eliminate it while they're all a half. 1, 0, 0. And then 4, 8 over 2 is 4, 1, 0, 1, 0, negative 3, negative 7 plus 1 is negative 6 over 2, negative 1, 0, 0, 1 half, 3, 7 over 2, 1. And now we can do 2 row 3 to make it a 1. 1, 0, 0, 0, 1, 0, 0, 0, 1. 4, 4, 1. Negative 3, negative 3, negative 1. 6, 7, 2. So our inverse is 4, 4, 1, negative 3, negative 3, negative 1, 6, 7, 2. That's our inverse matrix. Now, what's the point of finding an inverse matrix? I'll show you right now. We know that when we're solving, we can use the inverse matrix because x equals A inverse times B. And x is our solution, the solution to the system. So it's a nice, easy way. It's like a shortcut to solving the system. So they're giving us A inverse and the system. So B, remember, is right there. So x equals A inverse times B. A inverse is 1, negative 8 over 3, negative 1, 3. B is 3, 6. So if we multiply these, row column rule, we get 1 times 3 minus 8 over 3 times 6. And then we get negative 1 times 3 plus 3 times 6. This gives us negative 13 and 15. So our solution is negative 13 for x, 15 for y. Pretty awesome. I really enjoy that. Using the inverse to solve it, it's a lot quicker if you have the inverse, or if it's easily findable, if you can solve for the inverse quickly. It's a nice little shortcut.